Good morning, friends. In the previous lecture, we were solving the sums related to the area of triangle, right? Let us continue with some of the sums. Again, I am having a question, that is, if A minus 5 comma 7, B minus 4 comma minus 5, C minus 1 comma minus 6, and D 4 comma 5 are the vertices of a quadrilateral, then find the area. Find the area of quadrilateral ABCD. See, what is the question given to us? That here these 4 points, which are the 4 points given to us, that is A, B, C and D, are all 4 vertices of a quadrilateral, and we need to find out the area of the quadrilateral. So let us see how to find out the area of this kind of quadrilateral whenever it is given to us. So first of all, let us try to make a figure out of this. So we don't know that whether this is a square or rectangle or anything. So we shall draw a general quadrilateral without naming the type of quadrilateral, right? So that is my A, B, C and D. Right. Now I need to find out the area of this quadrilateral. So one more thing I would like to add here is I shall connect the diagonal A to C. Right? I am going to connect any one of the diagonal. It is not compulsory that you connect A to C only. Right? Because this is the first diagonal of my quadrilateral, so I am connecting A to C. You can also connect this B to D, and then you can simply find out the area, right? Now you can see here that this diagonal divides the whole quadrilateral into two triangles. The first one is triangle ABC and the second one is triangle ADC. Right? So this quadrilateral has now been converted into two triangles with the diagonal dividing it into two triangles, and these triangles has some area. That means the area of these two triangles can be found out by using the formula that we have, and then adding these both areas we get the total area. So here A, B, C and D forms a quadrilateral, and diagonal AC divides the quadrilateral into two triangles such that area of ABCD is equals to area of triangle ABC plus area of triangle ADC. Right? So that is our equation number 1. That area of quadrilateral ABCD equals to area of triangle plus area of triangle ADC. Now, area of triangle ABC, that is again given by half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So as we know that we need to find out the area of triangle ABC, we will take A as x1 y1, we will take B as x2 y2, we will take C as x3 y3. Is it clear? So we shall take these two A and C fixed as x1 y1 and x3 y3, and in triangle ABC we will take B as x2 y2, whereas in triangle ATC we will take D as x2 y2. So let us put down the values here, which gives me that is equals to half modulus x1, that is -5 into y2 that is -5 again, and y3 -6 plus x2 that is -4 into y3 that is -6 -7 plus x3 that is -1 into y1 that is 7 -5. Is it clear? So that is how we put the values. Now let us solve this. That is equals to 1/2 into -5 multiplied by -5 minus plus. So -5 plus 6 that is 1. Here plus minus -4 into -6 -7 that is -13. Again plus minus -1 into 7 minus plus, so that is 7 plus 5 12. Right? Let us simplify this now. That is equals to half modulus -5 plus 52 minus 12, that is half modulus 52 minus 17. Right? Half modulus 52 minus 17. So that is 52 minus 17. What is 52 minus 17? 50 minus, first of all check 50 minus 17. 50 minus 17, 33 plus 2, 35. So that is equals to half modulus 35, which is equals to 35 by 2. So we got the area of triangle ABC, that is 35 by 2. What is this? We got area of triangle ABC. Therefore, area of triangle ABC, that is equals to 35 by 2 square units. Right? 35 by 2 square units. Now, let us find out the second triangle. Now, area of triangle ADC, that is again using the same formula, right? That is equals to half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Again putting down the values, here we get that is equals to 1/2 modulus x1. So we take A as x1, that is -5 into y2. What is y2 we have taken? We will take now this D as x2 y2, not this B now. In the first case we took B as x2 y2. Now we shall take D as x2 y2, that is y2 5 minus y3, that is again -5 plus x2, that is equals to 4 into y3, that is -6. Sorry, here not -5, we will get it -6 here. So that is 4 into -6 minus 7 plus x3, that is -1 into y1. What is y1? 7 minus y2, that is 5. So we have put the values here. Therefore 1/2 modulus -5 into minus minus plus, that is 5 plus 6 11 plus 4 into minus 13, right? So I think this is good. Okay. X2, that is 4, y3. Okay. That is good. Here it is plus minus minus and 7 minus 5, 2. Right. So that is equals to 1 upon 2 modulus minus 55 plus minus minus 52 minus 2, and that is 109, right? That is 1 upon 2 modulus minus 109. 50 plus 50 100, and 100 plus 5 6 7 8 9, and that is equals to 109 by 2, because minus 109 is equals to modulus is there, so it will get plus 109. Therefore area of triangle ADC is equals to 109 by 2 square units. Right, now we shall use this first equation here. Therefore area of quadrilateral ABCD equals to, what is area of triangle ABC? 35 by 2. So that is 35 by 2 plus, what is area of triangle ADC? That is 109 by 2. So what is 35 plus 109? 144, right? 144 by 2, and which is equals to 72 square units, right? So the area of this quadrilateral is 72 square units. So friends, you can see here that this is how we can find out the area of any quadrilateral that is given to us. So here area of the quadrilateral ABCD that is given to us here is equals to 72 square units. Okay. So take a look over it, then again I'm going to remove this. Okay. Now you can see here that we are going to solve some questions that we have already solved before. The second one of today, that is find the value of k. Find the value of k if the given points are collinear. Find the value of k if the given points are collinear, and the points given to us that are 7 minus 2, 5 1 and 3 comma k. So these are the three given points, and it is said that these given 3 points are collinear. So let us say that here let 7 minus 2 equals to x1 y1 5 comma 1 equals to x2 y2 and 3 comma k equals to x3 y3. As they are collinear, the area of triangle is 0. Right? We know that for collinearity, if 3 points are collinear, then the area of the triangle so formed is 0. Therefore, we know that area of triangle, that is half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Right? We are having x1 y1, x2 y2 and x3 y3. Let us simply put here, in place of area of triangle we shall put 0. Therefore 0 equals to half modulus x1, that is 7 into y2 1 minus k plus x2, that is 5 into y3, that is k minus 2 plus x3, that is 3 into y1 minus 2 minus 1. Okay, so that is, we just put the values of x1 y1, x2 y2 and x3 y3 here in this formula. Therefore 0 equals to half modulus 7 into 1 minus k plus 5 into k minus plus 2 plus 3 into minus 2 minus 1, that is minus 3. Let us multiply everything inside. This 2 will be multiplied here, that will become 0. Therefore 0 equals to modulus 7 minus 7k plus 5k plus 10 minus 9. Right? So we got this here. What is minus 7 plus 5? Minus 2. Therefore 0 equals to modulus minus 2k, 7 plus 10, 17, 17 minus 9, that is 8. Yes or no? So that will become plus 8. Now you can see here that here this 2k minus 2k plus 8 is in modulus. Yes or no? Now we don't know that whether the value of minus 2k plus 8 is positive or negative. So we need to take both the conditions here. Therefore, if we remove this modulus, what shall we get? Therefore, plus or minus 2k plus 8 is equal to 0. Right? Plus or minus. We can take either minus also and we can take either plus also, because we don't know what the value of 2k plus 8 will be here, negative or positive. But for both of these values, the answer will be positive only. Therefore, plus or minus 2k plus 8, plus or minus 2k plus 8 equal to 0. Therefore, either minus 2k plus 8 equal to 0 or minus of minus 2k plus 8 equal to 0. Therefore, 2k equals to 8 and hence k equal to 4. And here if I take, that is again minus 2k plus 8 equal to 0. Therefore 2k equal to 8 and hence k equal to 4. So friends, you might come with a question, so that both the values are same. So the condition is that here if you take plus or minus, or if you take plus, or if you don't take plus or minus, it doesn't matter. Why? Because here the answer is always 0. If there is a non-zero term here, if there is a non-zero term, that means here if there is any number except 0, then and then you need to compulsory take here plus or minus. So from here itself, friends, you can directly write down that here. Let me write down again that therefore minus 2k plus 8 equal to 0. Therefore 2k equal to 8 and hence k equal to 4. Right? So we can directly write it down from this step itself that removing modulus we will get direct 0 and hence we don't need to perform extra calculation here. Is this thing clear? Right? So that is the value of k, that is k equals to 4. Okay? Okay, now I'm having another question, that is the second one. The vertices given are 8, 1, k, minus 4 and 2, minus 5. Right? We need to solve this question here again, given that these points are collinear. So if these points are collinear, then what will be the thing here, that is area is equal to 0. So here let 8, 1 is equals to x1 y1, k, minus 4 is equals to x2 y2 and 2, minus 5 is equals to x3 y3. As they are collinear, the area of the triangle is 0. So area of triangle is equals to half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So we got this here. Applying the values and area equals to 0, therefore 0 equals to half modulus x1, that is 8 into minus 4 minus 5 plus k into minus 5 minus 1 plus 2 into y1, that is 1 minus 4. So this 2 will go here, that will become 0 equals to modulus 8 into minus 4 minus plus, that is minus 4 plus 5 plus k into minus 6 plus 2 into 1 plus 5. Right? Let us solve this. Therefore 0 equals to modulus 8 into 1 minus 6k plus 5 plus 1 is 6 into 2, 12. You can directly write it down, 8 into 1, that is 8. Right? So that is 8 plus 12, 20. 0 equals to modulus 20 minus 6k. Therefore removing the modulus, that is 20 minus 6k, therefore 6k is equals to 20 and hence k is equals to 20 by 6 or 10 by 3. So that is the value of k for these 3 points being collinear. Is it good? Okay, take a look over it, then we shall move on to the next sum. Okay? Sorry. Now, the next one, friends, it is an important one, as we need to find out the triangle. The question is, exercise 7.3, question 3. I am reading the question that find the area of triangle formed by joining the midpoints of the sides of the triangle whose vertices are 0, -1, 2, 1 and 0, 3. Find the ratio of this area to the area of the given triangle. So first of all, I have a triangle here that is given and I am going to join the midpoints here. So joining the midpoints will give me this smaller triangle, the bigger triangle having coordinates 0, -1, that is 2, 1 and 0, 3. And friends, let the midpoints be D, E and F. Let us take the midpoints as D, E and F. Here, let the given points be A 0, -1 equals to x1, y1, B 2, 1 equals to x2, y2 and C 0, 3 is equals to x3, y3, and let D, E and F are the midpoints of sides AB, BC and AC respectively. Right? So we have taken these 3 points, 0, -1 as A, so this will be your A now, this is your B and this is your C. Right? Now we need to find out the coordinates of D, E and F first of all, then we need to find out the area of this triangle, and then we need to find out the ratio of the areas. So here, now using the special case, that is the midpoint theorem, of the section formula, we get D is equals to, D is the midpoint of AB, that means coordinates of A and coordinates of B will be taken as x1, y1 and x2, y2 respectively. So this is x1, y1 and this is x2, y2. So that is 0 plus 2 upon 2, comma, minus 1 plus 1 upon 2. Right? Which is equal to 2 by 2 comma 0 by 2 and which is 1 comma 0. So we got the first one, that is coordinates of D here, that is 1 comma 0. Now similarly we find out coordinates of E also. So coordinates of E is the midpoint of D and C, that is 2 plus 0 by 2 comma 1 plus 3 by 2. Okay, so this is how you can add up using the midpoint theorem, that is 2 plus 0, that is 2 by 2 comma 4 by 2. 2 by 2, that is equals to 1 comma 4 by 2, that is 2. So we got the coordinates of E, that is 1 comma 2. Similarly we find out the coordinates of F. So F equals to, what is F, friends? F is the midpoint of A and C. So that is equals to, F equals to 0 plus 0 by 2 comma minus 1 plus 3 by 2. 0 plus 0 is in fact 0. So there is no need to add up here anything. That is equals to 0 by 2 comma minus 1 plus 3, that is 2 by 2, which is equals to 0 comma 1. So we got the coordinates here, friends, of D, E and F, right? This is the coordinates of D, the first one. This is the coordinates of E and this is the coordinates of F. Now what do we require is, first of all we will find out area of triangle DEF, then we will find out the area of triangle ABC and then their ratio. Therefore now area of triangle DEF, that is using the formula half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so we will take the coordinates of D here for this formula as x1 y1, E as x2 y2 and F as x3 y3. So that is equals to half modulus x1, that is 1 into y2 2 minus 1 plus x2, that is 1 into y3 1 minus 0 plus x3, that is 0 into y1, that is 0 minus 2. Right? See friends, there are so many zeros, ones and twos, so be aware of putting the values, that is half modulus 1 into 1 plus 1 into 1 plus 0, which is equals to half modulus 1 plus 1 plus 0, that is equals to modulus 2 by 2. Therefore area of triangle DEF, that is 1 square units. This is the area of triangle DEF, that is modulus 2 upon 2, which is equals to 1. So we got the area of triangle DEF, that is 1 square units. Now we shall find out the area of triangle ABC, and area of triangle ABC, that is again using the formula half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so that is the formula. Now this is equals to half modulus. Now friends, as you can see that we are finding out the area of triangle ABC. So we are already having the values of x1 y1, x2 y2 and x3 y3. So now we shall use this values to find out area of triangle ABC, that is x1 0 into y2 1 minus 3 plus x2, that is 2 into y3, that is 3 minus minus 1 plus x3 equals to 0 into what is that? y1. y1 is minus 1 minus 1. Okay. So that is again 1 by 2 modulus 0 into minus 2 plus 2 into 3 minus minus plus, so that is 3 plus 1 4 plus 0 into minus 2 again, which gives me that is equals to half 0 plus 8 plus 0, that is modulus 8 by 2, which is equals to 4. Therefore area of triangle ABC is equals to 4 square units. So we got the areas of both the triangles here, that is area of triangle DEF is 1 square units and area of triangle ABC is 4 square units. Now lastly, area of triangle DEF upon area of triangle ABC, that is equals to 1 upon 4, that is 1:4. So the ratio here we require is 1:4. That means the area of triangle DEF is to area of triangle ABC equals to 1:4, right? That means again that the triangle ABC is 4 times greater than that of triangle DEF, right? Triangle ABC is 4 times greater than that of triangle DEF. So that is the answer of the given question. Now we shall move on to the question that is, I think, the last one of this topic. I'm having a question here that exercise 7.3 question 5. You know, friends, that in homework question 4 of exercise 7.3, you will do this one in the homework. Question 4 of exercise 7.3, that is same as that of the question that we have solved today, the very first question, I think. Okay, you need to find out the area of quadrilateral. So you will follow the same steps, just replace the values. Okay, so here we have that median of a triangle divides it into two triangles of equal areas. Verify this result of triangle ABC whose vertices are given. So let me draw a triangle ABC first of all. That is my A, B, C. A is 4, minus 6. B is 3, minus 2. And C is 5, 2. Right? These are the three vertices given. So here, given vertices A 4, minus 6, that is taken as x1 y1, b 3, minus 2 taken as x2 y2, and c 5, 2 taken as let me write down here, and C 5 comma 2 taken as x3 y3. Okay, so we have taken these three vertices A, B and C as x1 y1, x2 y2 and x3 y3. Now we know that a median divides this triangle into two areas, so we need to draw a median here. Friends, it will be a straight line, sorry, my mistake. So this is the median of this triangle. Let me name this as D. Now you know what a median is, so let me write down median. What is a median? So that is a line segment drawn from one vertex of a triangle to the midpoint of the opposite side of the triangle. That is known as a median. A line segment drawn from one vertex of a triangle to the midpoint of the opposite side of the triangle. So, if this AD, therefore, that here AD is the median, that is D is the midpoint of BC, right? D is the midpoint of BC. So what you can say about point D using the special case, therefore coordinates of D is equals to 3 plus 5 upon 2 comma minus 2 plus 2 upon 2. What is 3 plus 5? That is 8 upon 2 comma 0 upon 2, right? 8 upon 2 comma 0 upon 2. 8 upon 2, that is 4. So D, that is 4 comma 0. So here we got the coordinates of D, that is 4 comma 0, right? Now as you can see that we are having two triangles. The first one is triangle ABD and the second one is triangle ACD. So first of all we will check that we can get the areas of two triangles and it must be equal. So the area of triangle ABD must be equal to area of triangle ACD, and hence we can conclude that median divides the triangle into two triangles of equal areas. Therefore area of triangle ABD can be written as half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, and that too in modulus. Okay. So let us put down the values. We are going to take A as x1 y1, B as x2 y2 and D as x3 y3. We will take D as x3 y3. So let us put down the values here. That is half modulus x1, that is 4 into y2 minus 2 minus y3, that is 0, plus x2, that is 3 into y3, 0 minus y1, that is minus 6, plus x3, that is 4 into y1. What is y1? Minus 6 minus minus 2. Okay, so that is equals to half modulus 4 into minus 2 plus 3 into minus minus plus, so 0 plus 6, that is 6, plus 4 into minus 6 minus minus plus, so minus 6 plus 2, that is minus 4, which is equals to half modulus minus 8 plus 18 minus 16. Add up. Minus 8 plus 18, that is 10, and 10 minus 16 is minus 6, so that is modulus minus 6 by 2, which is equals to 6 by 2, and that is 3 square units. Therefore, area of triangle ABD is equals to 3 square units. Okay, so we got here the area of triangle is 3 square units. Similarly, we shall find out area ACD, that is half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, which is equal to, now we shall take, friends, x1 y1 as A, x2 y2 as D, and x3 y3 as C, because we are already having C as x3 y3. You can take in any order, there is no difference here. That is half modulus x1, that is 4, into y2 that is 0 minus 2 plus x2, that is 4, into y3, that is 2 minus minus 6 plus x3, that is 5, into y1 minus 6 minus 0. So that gives me half into 4 into minus 2 plus 4 into 2 minus minus plus 6, that is 8, plus 5 into minus 6. Let us solve this. Half modulus minus 8 plus 32 minus 30. So minus 8 plus 32, that is 24, and 24 minus 30, that is again minus 6. So that is modulus of minus 6 by 2, which is equals to 6 by 2, which is equal to 3. Therefore, area of triangle ACD, that is equals to 3 square units. Right? So we got 3 square units for area of triangle ABD and 3 square units for area of triangle ACD. Therefore, median of a triangle divides it into two triangles of equal areas. Right? So that is the conclusion, that median divides, or median of a triangle divides the triangle or it into two triangles of equal areas. And hence, friends, here we conclude this chapter, that is the coordinate geometry.